Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, and Circles. General form of the equation of a circle. Do you remember a few videos ago where we made the equation of a circle by putting the center and the radius in? We cleaned up a double negative, we squared the radius, and then I pondered out loud, should we multiply all the parentheses out? Should we write them twice in FOIL? And I said the answer was no, because you would lose all the nice things inside the equation. That doesn't mean you can't do that. It just means it would make the equation look different. And if you did that, if you eliminated the parentheses in the equation of a circle and got everything on one side, you would get what is called the general form of a circle. The general form of a circle is x squared plus y squared plus some x's plus some y's plus a constant is equal to 0. Like most general forms, it's just get rid of the parentheses and shove everything to one side, such as this equation. The problem with general form is the center and the radius get so blurred you can't see them clearly. That doesn't mean they're not there. That just means we have to work to get them. So let's work to get them. Sketch the graph of the equation, give the domain and range. So same directions as last time. But this time the equation is in general form. X squared plus y squared minus 6x plus 4y minus 23 is equal to 0. And by the way, not every equation of this form will actually make a circle. There is a condition that has to be satisfied for it to be a circle. I might make one more supplemental video. I'll make a note to myself over here. It will be optional because it's not really part of the college algebra discussion. When is general form not a circle? We'll answer that question. It'll be fun. But anyway, this one is, because I already know what the graph looks like. And believe it or not, you do too. Wait, what? You'll see. So how are we gonna graph this? Well, we gotta find the center and the radius, but how are we gonna find the center and the radius when this isn't in the right form? Remember, the correct form, or rather, the standard form for a circle is parentheses x minus h squared plus parentheses y minus k squared equals r squared. But this doesn't look like that. It has no parentheses, has too many terms. So how are we gonna fix this? Well, the way we're gonna fix it is we're gonna revisit an old friend way back from section 1.5. When we were solving quadratic equations, there were 4 techniques for solving them. The first one we did was factoring. The second one we did was solving square roots. The last one we did was the quadratic formula. But right before the quadratic formula, this is my ring finger, not my middle finger. Right before the quadratic formula, there was one more technique that we did. We used it to make the quadratic formula, and then we never looked at it again. Do you remember that technique? It was completing the square. Recall that what completing the square accomplishes is it takes 2 terms, but not like terms like x squared and minus 6x, and sets it up so that it will factor into the same thing twice, which is exactly what we need here. So, how are we going to complete the square on this? Well, the same way we did before, but now we're going to have to do it twice. Once for the x's and once for the y's. Let me kind of guide you through it. The first thing we want to do is rearrange terms. This isn't actually 100% necessary, but it just makes it easier to follow. Now the way we're going to rearrange the terms is we're going to start by writing the 2x terms. X squared minus 6x. And now leave a blank space after that because we are going to complete the square there. Then write the 2y terms. The positive y squared, the positive 4y, and leave another blank. You may recall when we completed the square that our first move was to move the constant term to the right because it probably wasn't the term that we needed. Saying it was good then, it's good now. Move the 23 over, it'll change signs and become positive. So gather like variables, leave blanks for completing the square, move the previously existing constant over to the right side. Then, complete the square twice. Once on the x's, once on the y's. Right now I'm just going to recopy what's currently there, and then we are going to complete the square. A reminder how to complete the square. For each binomial that's going to become a trinomial, it takes two moves. You look in front of the linear term, in this case x, you take half of that number, half of -6 equals -3, and then you square that. -3 squared is +9. I need a +9 there. But if I add 9 on the right, if I add 9 on the left, I also have to add it on the right. But I need to do this to the y's also. So from the +4, half of +4 is equal to +2, and +2 squared is +4. So I need a +4 in that blank, but if I add it on the left, I have to add it on the right. If done correctly, completing the square creates a trinomial that factors predictably. So our next move is to factor into squares. The x squared minus 6x plus 9 will factor into a square that starts with an x. And you don't have to guess the number in the middle. Just a reminder, in the completing the square flow, the number inside of here is the number you get after taking half of. Half of -6 is -3. -3 is what goes in the parentheses after the x. Do you know what will go in the parentheses after the y? What did we get when we took half of +4? +2. Looking good. The right side has 3 like terms to combine. 23 plus 9 is 32. 32 plus 4 is 36. Now, this does not finish the problem. This simply gets it ready. But now that the equation is in standard form, or what I would call center radius form, I can now extract the center and the radius and go to town. But doesn't this equation look familiar? Especially if you watched the last video. This is the equation from the last video. So we've already graphed this. We found its center, just to state it again. The center you get by removing the numbers after the x and the y, but you change their signs. So 3 and -2. The radius is the square root of this number, so the radius is 6. And we can plot the center and then go left, right, down, and up. Well, right, left, down, and up. Mine left, your right. We can go 6 from the center in 4 directions, replot, draw the circle, and then we can pull off the domain and range. But since it's the same graph as before, I refer you to the previous video, which should be titled 2.8.7. Sketching the graph of the equation of a circle. Click the playlist and go find it, it's there. So at this point I'm gonna end this video because we've already graphed this equation and given the domain and the range. It's in the previous video. The hardest part was preparing this equation to give up its center and radius by completing the square not once but twice. Once for the x's, once for the y's.